In 11.2, we're going to look at what is a logarithm, or what is a logarithmic function. And so to start, we talked about exponentials last time, and an exponential was f of x. I'm going to write it as y right now because we're going to write the inverse. So the exponential was y, or f of x, equals b to the x power. Okay, a log is basically the inverse of an exponential. And so when we talked about inverses, remember, to solve, the first step we always did was switch the y and the x after we wrote it as y equals. So I'm going to switch the y and the x, and we get x equals b to the y. So this is what a log is. It's still an exponential, but a lot of these exponentials we kind of have solved for us, and they're in our calculator, at least base 10 and base DE, and we'll talk about that later. And we can convert this log here. We have a formula to help us convert from log to exponent and vice versa. So if you have x equals b to the y, if it's written in exponential form, you can write this as your log. And this goes in either direction. This would be y equals log base b of x. Okay? And then if you have a log, you can write it as an exponent. So this can go back and forth. From x equals b to the y to writing it as a log, use this formula to help you. Writing from a log to an exponent, you can kind of think of it as like a circle. You start with the base, so it'd be b raised to the y power equals this x. And that kind of helps with converting from a log to an exponent. Okay, so let's practice converting the following to logs or vice versa. So if we have an exponent, we're going to convert it to a log. If we have a log, we're going to convert it to an exponent. So 64 equals 8 squared. First of all, that's true, but I just want to convert this. So I'll remind you that what we had on the other page was that x equals b to the y. So I can kind of show you x is 64, b is 8, and y is 2. And I want to rewrite this as a log. And so the formula was y equals log base b of x. So I'm going to convert from this to the log. So this would actually be, I'll move it over here. Your y is 2 equals log, your base is 8, so log base 8 of 64. So these mean the same thing. It's just two different ways to write the same thing. So let's do the same thing with b. 9 to the negative 2 power equals 1 over 81. Okay, so my y value is negative 2 equals log, my base is 9, and then, so log base 9 of 1 over 81. For c, I'm going to convert from a log to an exponent, and this one I always find a little easier. So you start with the base, and you go in that circle. That kind of helps you. So this would be 7 to the y power equals x. So these are equivalent, two different ways to write this. And the last one, we're going to do the same thing using that circle. This says 5 cubed equals 125. Now we're going to evaluate the following logs. And these ones are simple enough that we can evaluate without a calculator. So mind you, this is standing for an exponent. This is saying log base 3 of 27 equals what? I'll put x for now. If I rewrote this as an exponent, what this is asking me is 3 raised to what power is 27? So I'm going to do that circle thing. 3 raised to what power is 27? And in this case, 3, I'm going to erase this x and put the answer. 3 raised to the third power is 27. So log base 3 of 27 equals 3. Let's do the same thing with b. This is saying log base 2 of 4 is asking 2 raised to what power is 4? And that would be 2. 2 squared is 4. For c, log base 5 of 1, this is asking 5 raised to what power is 1? This is where you need to remember your rules of exponents. how do you get a 5 raised to number to give you 1? And that's 0. 5 raised to the 0 power is 1. So log base 5 of 1 is 0. And then this last one, 10 raised to what power is 100? That's what this is asking you. 10 raised to what power is 100? And that would be squared. 10 squared is 100. You can actually do base 10 on your calculator. We will be doing this later on. But if you take your calculator, you won't see this base right here written. Usually when it's base 10, we don't write the base 10, just assume to be base 10. So if you type in log of 100 on your calculator, you should get 2 as an answer. Okay, so let's write down a couple of special properties of logs. And the first one is that if your base and what you're taking the log of are the same, this is always going to equal one number. And so let me just show you an example. If I said we'll do base 10, log of base 10, remember we don't usually need to write this base, but I'm going to do it right now, of 10. So log base 10 of 10. This is saying 10 raised to what power is 10? And you can put this into your calculator. You don't need to type in the base. You just press the log button and then the number 10 and hit enter. You should get 1, and that's because 10 raised to the first power is 10. So when your base and what you're taking the log of are the same, this is always going to equal 1. The second property, and we just did this a minute ago, is that no matter what the base is, if you're taking the log of 1, or this is saying b raised to what power is 1, and again we can do base 10. This is saying 10 raised to what power is 1, and we said earlier that's 0. So it doesn't matter what the base is, if you're taking the log of 1, you're always going to get 0. Okay, so let's solve a couple of log equations. Log base 5 of x equals 2. In this case, when I go to solve, because the variable is part of this log, I can't solve like this. I have to rewrite this using that circle as an exponent. So this is equivalent to 5 squared equals x. And then I can just solve. That means x is 25. So same thing with b. If I go to solve, I need to rewrite this in exponential form. So this would be 7 to the negative 1 power equals x. Remember, to get rid of that negative 1, you need to write it over 1. So this would be 1 over 7. So x equals 1/7. Okay, so let's look at 2 more examples here. Solve log of base x of 64 equals 3. So in this case, my variable is the base. Again, I need to rewrite this in order to solve. So this is saying x raised to what power is 64? I'm sorry, x raised to the third power is 64. What is x? And I could take the cubed root of both sides, or basically it's 4 cubed. That gives me 64, so x is 4. This next example is a little bit different. We have log on both sides, and the base is the same. I have base 3 here and base 3 here. The only way the log of base 3 of x plus 2 can equal the log base 3 of 5 is if x plus 2 is equal to 5. That's the only way this is possible. So you can basically drop the logs and say the only way this is equal is if x plus 2 equals 5. Then go ahead and solve for x by subtracting 2, and you get x equals 3. Okay, to graph, we're actually going to do this a little bit differently. We can't graph base 5 on your calculator. You could do base 10, and so I'm going to show you a different way to graph. This is what y equals log base 5 of x. I'm going to rewrite it. And then I'm going to write this as an exponential. This says 5 raised to the y power is x. That's what I'm trying to graph. So I'm actually going to graph its inverse first. Whoops, let me undo that. And use the Okay, looks a little better. So remember the inverse means switch the x and the y, and we have y equals 5 to the x. We know how to graph that. We graph that in 11.1. It has y-intercept 0, 1, right? And it's getting closer to this x-axis, and it goes up. Remember, the steepness depended on what that number was, whether it was a 5, a 15, or a 2. Okay, and this was the point 0, 1. Okay, and then this is a good review of something we learned in chapter 8. Remember, inverses, the graphs of inverses are reflections along the line y equals x. So I'm going to try and draw that line here. This is y equals x. And so the graph of the log would be the reflection along this line. So I can start with, let's do blue, the 1 point, and the point would be reversed. So if the exponential goes through the point 0, 1, the log is going to go through the point 1, 0. And then I just need to reflect about this line as best I can. And when you're doing the homework, you're not going to be actually graphing. It's going to be multiple choice. You're going to pick the graph that works. So I'm showing this graph's a little smoother. This would be the graph of my log, y equals log base 5 of x. So all the log graphs are have this shape. It's just a matter of how steep they are, or how close to the axis they are, depending on what this base is. So that's how I would graph a log. Let's also talk about the domain and range. So remember, for the exponential, the domain here was all real numbers, and the range was y was greater than 0. So I'm going to write it in interval notation. When I come to the log, the domain and range are actually going to be flipped. You can see that from the graph, and that makes sense since they're inverses. The domain, your x values start right after 0. And your range, all y values are used. Okay, let's look at one example. We're going to look at sound pressure. This is one time when logs are used. The level of sound pressure is given by this equation. S equals 20 log P over P sub 0, or P is the actual sound pressure, and P sub 0 is the threshold of human hearing, which is 2 times 10 to the negative 5. A sound at the pain threshold has a sound pressure of about 20. Calculate S, basically sound pressure level. So I'm given P and P sub 0. P is 20, and P sub 0 is 2 times 10 to the negative 5. That's just written in scientific notation. Find S. You should be able to put this into your calculator exactly as it is. There's no base written here, which means it's base 10. So just type in 20, hit your log button, parentheses, 20 divided by, and then put in parentheses 2 times 10 to the negative 5 power, and end with 2 parentheses. And when you do that, you should get a nice whole number of 120, and the unit for this is decibels.